For example, number 4, we're asked to differentiate the square root of x, where x is greater than 0. So what we're going to do is, let me just draw out the graph of this. And there's a reason that we're actually not taking it greater than or equal to 0, that we're just taking it strictly greater than 0. So let me draw out the curve for you. So remember, the square root function looks something like this. And I'm going to grab an arbitrary point on it, just as a visual. Okay, so let's grab this point right here. And then I'm going to grab another point in a second. Before I do that, let's just call this some distance out. I don't know what it is, but we can call it any variable we want. In fact, I'm going to call it something different than x, because we've been using x in the last couple of videos. So let's just call it a. Okay, so then this height value right here, if this is a, this height value is square root of a. Now let's grab another point a little bit over. So let's travel a ways over to right here. And let's call the distance that we travel, because this is the x-axis, we're going to call it delta x, or the change in the x value. So that means that this new point right here is going to be a plus however far I went over. Okay. And then what we're going to do is we're going to find the height of that point right there. And so that guy is the square root of a plus a little bit. Now what we want to do is we want to find the slope of this line right here so our goal is to find the slope of the purple line. That's the word line. It doesn't even look like it, does it? Let's rewrite it. Okay, so we're going to find the slope of this line right here, but what we're going to do is we're going to let delta x get really, really small. We're going to let it approach 0. We're going to take the limit. And so what that's going to do is, by taking this guy right here and making it really small, it takes these 2 points, this one right here, and this one right here, and it takes this point and pushes it towards that point, right? Because we're making this thing smaller. So to find this guy right here, to find the slope of this tangent line right at this point, what we're going to do is we're going to take the limit as this distance right here goes to 0 of the slope of the purple line. Well, the slope of the purple line is given by the change in the y values. So that's going to be a plus delta x, the square root of that guy, minus the square root of a. That's the change in the y values. Essentially, on the graph, that's this length right here. Okay, that's this. And then we're going to divide that by the change in the x values, which would be a plus delta x minus a. It's going to be this guy minus this guy. That gives us this length. But that, if you do the subtraction here, once we simplify, that's just going to be delta x, which is just this guy right here. And that makes sense because it's this length. So when you get to this point right here, by the way, these guys cancel out. One's positive a, one's negative a, so you just get delta x. But delta x is going to 0, so we can't just do a direct substitution here, because otherwise our denominator is 0. So we have to follow those limit laws from the last section. So let's go ahead and work this guy out. This is going to be the limit. I'm just going to rewrite it so that it looks a little bit better. Just like that. I need more space, so I'm going to move it over here. Now you might say, well, in the last problems it was easy because I could just factor out a delta x and cancel these guys out. Here, it's not that easy. So what I'm going to do is I'm going to multiply top and bottom by the numerator, but I'm going to change the sign in between. So watch this trick. We're going to go like this. And again, the reason that I have to do this is because I can't just take the limit directly, because this guy is not defined when delta x is actually equal to 0. So I've got to go ahead and find another function that behaves just like this function right here, except that it actually is defined when delta x is 0. So what we'll do is we'll multiply the numerator and the denominator by the numerator with the opposite sign in between. Okay, so what does that give us? Well, if we simplify, if you multiply this by this, the middle terms cancel out. I'm going to write it all out for you, but you'll see that the middle terms cancel out and you wouldn't normally have to do this. So watch. It'll be, it's going to be a lot of writing here. Right, because what I'm doing here is I'm taking this guy and I'm multiplying it by this guy. So I got to take this first guy, multiply it by this first guy, then I got to take this first guy, multiply it by the last guy, and right, we're foiling. So I'm going to have remember, when you multiply fractions, we don't have to have a common denominator, only when we add or subtract. So I'm just going to take this and multiply it by that, and I'm actually not going to multiply it in. I'm just going to rewrite it. Okay, like that. Now, excuse me, this guy right here and this guy right here are opposites of one another, so they're going to cancel out. And I have the square root times the square root, which is just that guy on the inside. And I don't have to worry about using absolute value signs here at all, because I know that a plus delta x has to be positive, because otherwise we couldn't take the square root of it. Right, so we're good there. And then we've got minus square root of a times square root of a again is a. And then this is over delta x times the square root of a plus delta x plus the square root of a. So you can see that these guys right here cancel out. And so all I'm left with on the top is delta x, and I've got a delta x out here in the bottom. There's multiplication. So this will cancel with this, and that leaves just 1, the number 1, on the top. So this reduces to the following. Okay. Now as delta x goes to 0, this guy right here, I'll do these limits separately so you can see here. This is equal to 1 over the limit as delta x goes to 0 of the square root of a plus delta x plus 1 over the limit as delta x goes to 0 of the square root of a. Okay, so this right here, this first part right here is equal to just 1 over the square root of a, because as delta x goes to 0, this guy goes to the square root of a. So this is going to be 1 over the square root of a. That's this first guy. And the second guy, this is a constant because delta A, or excuse me, A is not changing as delta x changes. A stays where it is. A, whoops, where did my guy go? A is just this guy right here. So this thing is equal to 1 over the square root of A. And I have got two of these guys down here at the bottom. Actually, sorry, when I wrote this wrong. This has got to be like this. There. Just think about why I in all my talking there, I had miswrote that. Like this, and so this is 1 over 2 square roots of A. So we have f prime of A now, not of x, because A was our variable that we were looking at. F prime of A is equal to 1 over 2 square roots of A. That's our derivative. Or, if you like x's, you could say f prime of x is equal to 1 over 2 square roots of x. Or, you could say this, f prime of something is equal to 1 over 2 times the square root of that something, right? That's just a placeholder. So this variable doesn't matter, right? Okay. So that's how you go ahead and differentiate. Oops. We're going to go ahead and differentiate this, okay, where x is greater than 0.